All right, good morning and happy Sunday. It's July 9th, and I'm planning on doing the LeetCode contest from yesterday afternoon. So share my screen here. And contest. Okay, so 353 from yesterday. So I participated in the bi-weekly contest, and I got the third question, which was super cool, I think, is basic brute force, DFS, do DP. But anyhow, the server was busted, so that doesn't count from yesterday morning. I'll do the one from yesterday afternoon now. So here we go. Okay, it is time to shine. It's 6:20 in the a.m. Open these guys up and we'll start jamming. Okay, 6:20. Oops, Q1, 6:20 a.m. Here we go. This goes down by one, the other one goes up by one. Man, what is this? X equals 5. Increase or decrease X by 1. No more than T times. It can increase or decrease num. What is X initially, though? Maximum achievable X. Decrease X by 1 and increase num by 1. Oh, that they're equal. Okay, so it should be num plus 2 times T. All right, num times 2 plus T. Num times 2T. All right, this is X. T return X times 2T. Right, something like that. Let's see what happens. 6 and 7. Oh, okay, never mind. That's not right. Oh, I thought it was. Oh, plus, right? Num plus. Oops. X plus 2 times T, right? That's what I want as a typo. Okay, 6 and 7. That's what I'm looking for. That looks good. Okay, cool. 6:22. That took about 1 or 2 minutes or so. 1 or 2 minutes. Oops. Patient Python 3, which is accepted. Yay. Okay, that's cool. That's kind of stupid though, right? Yeah, and whatever. I guess it's practice like reading, extracting requirements from the problem statement, but that's all there is to it, really. Oops. So if it goes lambda, oops. I might as well just stick this in a one-liner, and then let's post these real quick. Oops, discuss. Kind of silly, but oh well, that seems. I'd prefer an easy question compared to like a tricky question. I really kind of care less for the tricky easies. Oh, come on. Why is this thing taking so long to load? Ah, man. LeetCode servers are just like totally sucky. A few solutions. Turn this guy. Use the equation. To return the value. Okay. Okay, give it input x t 3 plus plus then JavaScript. Okay, return x plus 2 times t. the script. Spat. Bar. Let's do this. The rest will be the last one, and then we'll move on to Q2. Okay, oops, there we go. All right, use the equation x plus 2 times t to determine the maximum value given input x and t. Alrighty, there's that, and that took about 5 minutes. 1 hour, 25 minutes left for Q2. 6:26 in the AM. We have 1 hour, 5 minutes left in the contest. We have numbers and the target. Here we go. Negative target. Okay, so the absolute difference is less than or equal to the target threshold. Number of jumps we can make. Go from any I to J. Such that the absolute difference is less than or equal to the target. The maximum jumps. Okay, so we want to. It doesn't really matter where I and J are. Wait. No, I is left to the left of J. Does that matter? Go from I to J, from left to right. 0 to 1, since the absolute difference is less than 2. 1, 2, 3, 3, 2, 5. There are no jumping sequence with more than 3 jumps. 0 to 1, 1 to 2, 2 to 3. Okay. Right. There is no jumping. Okay, so anyhow, this one seems like we can do DFS, right? Game plan is DFS, right? Just trying to find the best. F go 0, and then we'll have our total jumps at each ith index, which will return at the end n minus 1, 0, 1, 2, 3, 4, 5. Okay. If I is equal to n minus 1, where n is the cardinality then for a, then we'll return 0. That's our base case, right? Base case. Turn go is less than our infinity, right? Or I go let go. By 0. The maximum best will be 0 initially. Return best at the end here. Turn go at go, otherwise -1, right? Okay. Okay, so candidate jth positions are those indices which are less than or equal to the target for the absolute difference, and it's to the right of I, or J in range, I plus 1 to n non-inclusive. If the absolute difference between a sub I and a sub J is less than or equal to our threshold T, then we're allowed to jump there. Best equals the maximum of best, and 1 plus go I plus, oops, to J, T plus 1 hops. Return T, right? Maximum T. Wait, best is the maximum total. Okay. Best initially equals t. Okay, something like that. Maximum. Okay, let's see what happens here. 4, that's not right. 4 is not right. T 0. We'll pop each time we recursively go. 1, 2, 3. That's just the maximum. Wait, hold on. Let's go T at the end here. Let's go to the right. 3, that's right. Okay, 5 and -1. 5, -1. Okay, that looks good. So this will TLE, right? I expect it to TLE. I'll add a memo and it should work. Oops, what did I do? All right, TLE. All right, come on, TLE. All right, cool. And then, so that TLE did expected, had a cache, should be good to go. 36 looks good. Big money, no whammies. Maybe I need bottom up. Oh crap. Okay, so this still TLEs. Almost passed most of them. Right. The cache, I was not expecting it to TLE. So TLE at 6:32. About 6 minutes. Okay, so let's see. That's surprising. Like with the cache. I guess, okay, so maybe we should. Suppose we should cherry pick the minimum J, right? Okay. Instead of considering all J, we can just break on the first, at the leftmost J. Like, yeah, so if you TLE, a lot of times you can do some pruning, right? Pruning of suboptimal legs. Let's just do this. What if we just turn here? Otherwise, return 0. If that still works okay. So the very first J that's valid is where we'll break, right? It makes sense to cherry pick the leftmost J, right? Okay, and then did I? Okay, well, let's see what happens. Ooh, okay, that's not right. One hop. Oh, okay, I get stuck. That's not right then. Okay, this is suboptimal or incorrect pruning condition. Okay, so move this so it doesn't GLE. Target. Order matters, right? Oh, I wonder if we can memorize. Well, I don't know. Let's try this in reverse then. Oh, crap. Okay. Right. Okay. So, yeah. So T can be propagated as a recursive stack of lines, right? I wonder if we can memorize just the ith state without T, and if that would be accepted. So, right, instead of bringing the T over, turn to 0, and propagate T as a recursive stack on Y. Or just one additional hop. This is the maximum itself, and that 1 is 0. Okay, let's see what happens here. That should be -1, right? Target 0. It doesn't go anywhere. What happened? It's just returning 1 instead of -1. The heck? This thing going? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. But then it doesn't actually get to this one though. It's up here. Is it up somewhere? Action. Infinity. So we don't get a best if exceeds 0. Okay, so it's -infinity. It should be -1. Right? Okay, cool. Here, no. Bam, bam. Okay, that looks good. Let's see what happens. All right. Okay, cool. So that worked out. That is pretty awesome. So instead of memoizing the state, which would have int, we return t as a recursive stack of lines, and we just memorize I. That's accepted, right? So if we try to memorize both I and t, it's resulting in TLA. Okay, so there you go. There's our base case, right? Base case. Let me just pick this up here. And I hope this is helpful for other folks because some of this stuff is tricky, right? And it's not necessarily straightforward or naive, right? Okay, forget. It's our recurrence relation target. This is our base case. There's our memo. Okay, and that's pretty much it, right? That's our constraint. Threshold constraint. Threshold T. Threshold. I don't know. We want to put this thing. Absolute difference. Threshold T constraint. Yeah, that sounds good, right? And then let's do this. Let's do this bottom up as well, right? So we should be able to mimic the recursive stack unwinding explicitly and recursively. Let's see. So we'll do dp will be our states. Negative infinity times n dp sub n minus 1 is equal to 0, which is our base case. Or I in reversed range n minus 1 non-inclusive. So that's from n minus 2 down to 0 inclusive. S equals negative infinity. Oh, actually, best will be dp sub I. Right, so let's just grab these things and we'll transform it as we go. Oops. Okay. Go. There's that and that. And then this will be dp sub j. And this guy will be I plus 1 to n. So we go backwards I, big I, and j goes this way. Looking at the previous I. So yeah, that sounds good. Okay, so instead of that would be dp sub I is the best solution. dp sub I is built on dp sub j, and that's our explicit recurrence relation. I explicitly is a recursive stack of lines, so dp sub 0 if it exceeds 0, otherwise negative 1. So face case we build on. Okay, I think that looks good. Let's see. Oh, this is our memo. Hold on. Grab this guy. Okay, let's see what happened. Okay, that looks good. I think. Did all right? Yeah. Okay. So that's bottom up. Okay, cool. So this will be posted as the art of DP because this is tricky. I think it's tricky. I've been practicing this for a few years now, and I still get kind of fumbled up. Well, hopefully this is helpful. Like I mentioned a handful of times. I'm not doing this necessarily just for myself, hopefully I can help out others as well. Yeah. But obviously, yeah, I have significant room for improvement. Okay, well, then, yeah, let's just grab this and I can write the solutions here real quick in the other languages and then we'll move on. All right, so let's do this. Grab this guy, which is basically a very verbose description of what it means all in return. Okay, grab this guy. Bam. Bam. Okie dokie. Doop doop doop. Python 3 solutions. Grab these and copy and paste them into here. And then do it for the other languages as well, just for practice. Okay, and then, yeah, okay, that looks good. Got this. Plus. And do Rust, C++, Python 3. JavaScript. Okay. Okay, so Python is super simple for the memo in that we just like basically stick the at cache thingy on there. Okay, so that's that. Oops, hold on. I'll grab this one for the memoized version, right? So it implicitly stores the optimal solutions as the recursive stack unwinds, right? And we optimally build the best ith solution based upon previous jth solutions, right? So building the future based upon the past, right? Optimal future based on optimal past. Okay, so there's that. Alrighty. And let's do this in the other languages here real quick. All right, let's jam. This shouldn't take very long. So let's see. That was Q2. That was done. Oh, I didn't track that, did I? Oops. Hold on. Q2 was done somewhere before 6:46 a.m. 20 minutes. Oops, minutes. Oops. For implementation. Oops. And Python 3. Python 3, which is accepted. Yay, both by top down plus bottom up. Yay. Okay, that's cool. All right, there's that. Then stiff threshold T constraint. Okie dokie. It is 6:47 a.m. and it's time to shine. Go will capture itself in its own recursive lambda, so we have to yeah, otherwise we can't invoke itself within a recursive closure, right? If we use like auto, that wouldn't work. Function. Look like. Okay, so if I is equal to cardinality of the input array A unless one's 0, otherwise return best solution. Best be negative infinity. Yeah, it's better than 0. Okay. And then for auto J, until n non-inclusive, case less than n. If the absolute difference between a sub I and a sub j is less than or equal to our threshold t, S is the maximum of itself. Let's go J. Okay. It's good. That should TLE. Put some comments in here. It's our base case. All right, and then this is our recurrence relation target. That's what we're trying to maximize. Okay, we'll add a memo and then that should be accepted, right? So that took about 2 minutes and 6:49 in the AM. Our memo will be a map. Oops. App. That's our memo. Okay, and then if and the ith best memoized yet. Memorize the ith best here and return at the end here. And that should be accepted, right? Okay. That's good. That's cool. Okay, add the memo here. Memo. By the way, I should mention, I'm up for answering any questions anyone has. So feel free to please post any questions if I'm able to help. If I can, I will. Right, I'm here definitely not just to help myself, but to help others. Right, this is not necessarily that straightforward, especially explicitly changing the implicit bottom or top-down solution to bottom-up solution. That's probably the trickiest part, in that we have to explicitly specify the base cases to be iteratively built upon, and then we also have to understand how the recursive stack unwinds, right, to basically transform this thing from top down to bottom up. It's two. So I goes from right to left as the recursive stack unwinds. Say so. VIDP will size in negative infinity, dp sub 0 or in minus 1 is equal to 0. That's our base case. Right, this guy here is our memo. And then basically just grab this and then replace best with dp sub I, which is basically the same thing, right? Okay, then it's recursive stack of lines. It'll propagate back up to dp sub 0. D sub 0. And this is each dp sub I state, right? So we build optimal i's based upon like current i's based upon previous j's. Right? Build the future, optimal future based on the optimal past. Uh-oh. What happened? What is it complaining about? Oh, I don't need function. Let's say solution. What? I missed something? Commenting something out? What the heck did I do? Oops, so that'll do it. A very useful error message, but okay, here we go. All right, that's cool. So there you go. C++, top down, bottom up, 6:53 in AM. It's okay. So that's cool. Boom. Okay, there's C++ solutions, right? And then the last C++ solution already got these, right? So here we go. Just got this guy. Stick it down there. Target. Oh, wait, I forgot to mention the constraint, right? I mean, makes things a little bit more interesting to have a constraint, right? Absolute difference. Threshold. Threshold. T constraint. Oop, line these up. Oop, that up. Okay, let's uncomment these. We'll just copy and paste down that comment for consistency. Maybe you'll see what I see. Okay, there's that. This guy. Oop. Okay, and then this guy. All right, and that's C++. It took about 5 minutes or so, which is cool. Okay, so there's C++, Python 3. We'll do Kotlin and JavaScript. I'll be right back. I drank a lot of coffee. I have to pee. Alrighty, we're back. Okay, so we'll do Kotlin, JavaScript, and Rust, and then we'll move on here. And we've got 53 minutes left in the contest. So we have enough time for Q3, maybe Q4. So let's do this and move on. F is number 7. Right, and then go. Initialize to 0. 0. Turn goes less or exceeds 0. Yes, then go. Otherwise, -1. If n is a.length, write the cardinality for a, and then if I is equal to n-1, return 0, and the recursive stack all in line to formulate the optimal total t hops we can make. And then for j goes on +1, j is less than n, this is j. If the absolute difference between a sub I and a sub j is less than or equal to our threshold t, then best equals -infinity, return best. Oops. Best here. Best is the maximum of itself and 1 plus go sub j, right? So we're building h optimal I based on previous j. So that works. I believe it'll TLE. So let's just add a memo here real quick after we add the comments, right? Here's our base case. That's where we'll reach at the end here, and that's where the recursive stack will align if we reach there. It's our recurrence relation target. Okay. There's this guy. JavaScript. Bam. Okay. And then let's add a memo. I didn't keep track of time. Dang it. Okay. It'll only take a few minutes, I think. This should be pretty fast. Okay, so M is our memo. And this new map. This is our memo. If not m.has I. Right, so we haven't memoized the ith state yet. Okay, so m.set I to the best solution, m.get I. It's the best solution memoized. Okay, that looks good. This should be accepted. All right, and then we'll add a comment for our memo here. Memo, oops, and then I also forgot to add the constraint too, right? So here's our constraint. Right, this is the absolute difference threshold t constraint for the problem statement, right? Okay, and grab it with the comment for consistently. See, you can see what's going on. Okay, then grab this guy. That one's cool, right? It's good. Yeah. Then we'll turn it upside down. Okay, if we turn it upside down, we don't need a memo here, but we do need a memo explicitly stated as an array n filled with -infinity. dp of n-1 is equal to 0 is our base case. And then as the recursive stack unwinds explicitly, our I will -2 down to 0 inclusive. All right, we'll just grab this stuff. Let's see, so our memo is explicit, it's no longer implicit. And then grab these guys here. dp sub I will be our best solution. That is dp sub I is built upon previous, like the current dp sub I is built upon previous dp sub j. And dp sub I and j is over here. Right, so that checks our state explicitly. Okay. over a little bit so it lines up, and then this is dp sub 0 has a recursive stack of lines, so we eventually reach back to I equals 0 state. Okay, that's cool. Okay, we got outline and rest, and then move on. Let's get to it. Go, 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 go. And it's the Cordelian for array A. If I is equal to n minus 1, that's our base case, which will return 0. Right, best infinity. Turn the best here at the end here. And as the recursive stack of lines, the maximum will be our best for j and I plus 1 till n minus 1 inclusive if the absolute difference between a sub I and a sub j is less than or equal to our input threshold t, then best is the maximum of itself and 1 plus go to j. Okay, so this should TL if I were to submit it as is without the memo, target, I think, yeah. Right, it says end is 1,000. Okay, so that should work for these small sample test cases. Right, that's cool. Oh, actually, that's before we forget again. This is our constraint, right? Absolute difference, threshold T constraint. Okay, so I think that's cool. Just to get here. Add a memo. Oops. Beautiful math. Okay, so if not map.contains doesn't have the ith value memoized, calculate the answer once and then store it for potential future lookups. M sub I is equal to best. Turn M sub I at the end here. Okay, so this should be accepted, right? We're not going to have to solve the same problem over and over again. Big money, no whammies. Okay, cool. This guy's good to go. Align this comment. White space. Looks nice. Okay. Looks good. Looks good. And then turn the bottom up solution upside down to explicitly formulate the bottom up solution. Oops, hold on. Let's do this. Oops. Uncomment that. And then I want to add in the memo here real quick. Check our memo. And like I mentioned previously, I wrote an entire document, right, a whole article about what this means to turn this thing upside down, what the memo is and such, right? So it's implicitly the base cases and such, and explicit, the memo is explicitly built from the bottom up as a recursive stack on lines, right? And then here we're just iteratively, well, when we turn the top-down solution bottom up, we're basically iteratively doing what the recursive stack on lines does implicitly. Right, so to go from the implicit to explicit transformation can be challenging, to say the least, right? This one is not too bad though, right? And some are quite a bit more difficult. Put this thing up with negative infinity. dp sub n minus 1 is equal to 0 is our base case. So there's our explicit base case. This is our memo. There. Okay, so for I in n minus 2 down to 0. then these actually, and so JN, just grab this. Let's show you all explicitly. Oh, I guess we can grab it from here. Show all explicitly this transformation kind of live. All right, so best solution for this state is stored in dp sub I as our current state, which is built upon our previous state, dp sub j, right? J is to the right of I. Okay. Target, and then let's go with dp sub 0. So as the recursive stack unwinds, we go to the original problem itself at dp sub 0. Okay, that should be cool. All right, there you go. This bottom up coupling. Okay, and then we'll do rest at the very end here. Rest is by far the greatest challenge for me. This up a little bit. And okay, so function go, take A as a reference, take T by value, that'll be a U size, return I32. Infinity equals 189, that's I32 plus 7. Turn if go is exceeds 0, and then we'll return it. Otherwise, return -1. If I is equal to the length of A minus 1, actually, we use a couple spots here. Okay, and then yeah, whatever. A little bit less to type, fine. Oops. Okay, and then for j and I plus 1 until n non-inclusive. If the absolute difference between a sub I minus a sub j is less than or equal to an input threshold t, then we can say mutable best is -infinity. Return best at the end here. Best is the maximum of itself. Let's go j. Okay, let's see what happens here. Go, oh, fn go. Okay. There, capture. This then. And oops. You know, like non-inclusive. This is why rest is kind of a pain, right? I don't know how to write a recursive lambda in a way that I could pass in a and t and all these kind of boring things, right? Like, oh, oops, this is going to TLE. All right, well, I need to add a memo. Right, okay, TLE is expected. Just add the comments here real quick, and then we'll add the memo for acceptance. This is our absolute difference. Oops. Threshold T constraint. Target. At the recurrence relation target. Okay, stick this here. Oops, yeah, there. Okay. Let's add a memo. All right, so use the actions hash map. HM equal to hash map new. Okay, and then if m that contains key ROI. M is our memo we have to pass in as a mutable reference. Let's do this. Hash map usize 2932. Mutable map. Mutable. It's a mutable reference, right? Okay, so if it doesn't contain the key, this is our best. And insert I best. Return m dot get I dot clone. So don't consume it there. This guy unwrap. Yeah, I should location of that guy, right? What's a let's see. Let mute best equals negative. Oh wait, hold on, I already got it there. Okay. Best is here. There's our base case. Okay, let's see what happens here. Oh, good passing the memo out. Looks good. That's cool. Okay, let's turn it upside down and then we'll keep going. Let mute dp, the vector size, let me n is a length. Vector of size n with the values negative infinity. Let's do this. Infinity is this guy, negative infinity. N of those things, dp sub n minus 1 is equal to 0 as our base case. And then has a recursive stack unwinds I n 0 until n minus 1 non-inclusive reversed. All right, and then we'll grab this guy. Instead of best, we'll use dp sub I to track each state. All right, so here is our memo. Oops, actually, we want to stick it over this way a little bit more. Might line these things up. Oops. Okay, and then this guy will be dp sub I, which is the current ith best is built on the previous jth best. Piece of j. Previously seen j to the right of I goes this way. Oh, okay, actually, I don't need these. Need to go over there. Okay, well, that's good. dp sub 0, if dp sub 0 exceeds 0, we'll return dp sub 0. Otherwise, return -1. All right, okay, so that should do it. Let's see what happens here. Looks good. Okay, that's cool. Oh, I don't need the hash map, actually. Let's get rid of this. Should be okay like that, right? Okay, cool. All right, that's all she wrote for this one. I really beat it up good. I guess, yeah, we build current optimal current ith solutions on optimal previous jth solutions. Okay. You use that to pass the optimal past to formulate the optimal future. That is, build current solutions based on previous solutions. Down, let go sub I. The best, right? So that's top down and bottom up. EP sub I. Okay, that looks good, right? Already dynamic programming. Kotlin, JavaScript, Python 3, Rust. Oops, the white space is off right there. Okay, let's clean up the Rust solution real quick. White space is off. Kind of sloppy, right? Oops. This should be cool, right? Oops, I think it's cool. What the heck just happened? Okay, yeah, I think that's right. Get to my solution here real quick. Okay. Then I'll just fix the rest. It's when the white space is no good. This guy. Oops, not this guy, this guy. Okay, that looks good. Okay, yeah, that's cool. And actually, let me push this onto this guy real quick. This one is fun. I really enjoyed the DP that I can do like this. I think it's cool. Okay, where's my guy? Here it is. Got this guy. Stick it here. I'll grab it and stick it here too. Yuki, let's see, you want to put it here. That looks good. And then we'll also update it here. Okay, so grab this guy and then just commit it here real quick. Oops. Okay, so there's that. Hopefully it's helpful for some folks. And then, okay, we got 27 minutes left in the contest, down to Q3. Longest non-decreasing separate from two rays. It's non-decreasing separate. This guy. That non-decreasing, so it's not strictly. So it can be the same or bigger, right? Same or bigger. Okay, so here we go from the same to the same. 1 sub 0. One to 2 to 3 to 4. Doesn't really matter where we go. So we could probably just sort them, right? Pre-process the input by sorting them. And then do a linear scan. I don't know, this pre-process input, right? Sort, then linear scan. Do we have to go between? Like, do you have to alternate? No. A, B, and create C then, right? Like the merge sort. H A sub I phi and C H B sub J phi, we'll choose optimally. Well, I is less than, do this, and J is less than N. One or the other. I think this will return to the end here. Cool. Okay, so let's just do both, and then at the end of the at the end of the loop, we'll consider singles. Those are both sorted. Okay, so if A sub I is less than A sub J, we'll take it T J solution is how many we take. It should be just be I plus J then, isn't it? Turn I plus j, right? How many we traversed? Okay. If that is true, this guy is less than that guy, then we can increment I. Okay, so the game plan is greedy. I plus equals 1. J is less than base I. J plus equals 1. This. And if I is equal to n, right? If we run out of i's, then we can take the remaining j's. So if that's exhausted in the other direction, right? So if b sub j is exhausted, oops, this should be b sub j. B sub j. B and B. Okay. This guy will move I forward. J is in, but then I is less than this guy. So the I with B sub n minus. Right. So consume the remaining j. In that case, consume the remaining I. In this case, return I plus j. Okay, let's see what happens. 5. That is not right. Why can't we do 1, 1, 2, 2, 3? Why is that not working? Right, that's what I'm doing basically. 1, 1, 2, 2. Actually, no, it should be 1, 1, 1, 2. It should be 6. I think I did it right. Oh, I can only choose I once, then each I value can only be chosen once. That's this one or that one goes to. Ah, okay. So each ith value is either this one or that one. Okay. Oops. Okay. Oops. Misread the problem statement. All right. So we want to or cannot, since each ith value can be consumed only once. Right. Okay. Right. So either we take a sub I or b sub I, XOR, right? Exclusive or either, right? J was never constructed in C. Suppose we want to take the minimum of both of them as we go. Maybe even skip it. Wonder if it's a monotonic. Can we use a monotonic queue? All right, question. Can we use a monotonic queue? So if we have the choices, let's just play with the input for a little bit as we come up with a game plan. All right, so here's example one. A equals 2, 3, 1, B equals 1, 2, 1. And we can take each of these ith values once, 0, 1, and 2. So would we want to take 1 or 2? I think it makes sense to always take 1. Isn't it always take the minimum? Makes sense to cherry pick my minimums. Maybe more difficult choice is when to skip values. Right, so either we add it onto the existing there, or we go back, skip it, and we so yeah. So what if it was right? So it was like A equals 1, and then like 1,000, right? And then 2, 3, 4, 5. Similarly, if B equals like 1, and they're saying 1,000. Makes sense to skip 1,000. So if we're using a monotonic queue, we'd pop off 1,000 and put 2 on it. Let's try. I think this seems promising. Use a monotonic queue. Yeah, let's see what happens. 7:35. And okay, we're getting close to the end of the contest too, right? It's 15 minutes left. Let's try to finish this one off, and then I'll upsell Q4 another time. Fresh. Okay. Anyhow, if we use one monotonic queue, it'd just be a stack, right? So 4 only in range in low will be the minimum of base of I and a sub j. Lowest ith value. Best solution. 0 initially. Best will be the maximum length of the monotonic queue. If not length s, or if length s, right? Length s. And while I say, okay, so while I have to kick it out as top of the stack exceeds the lowest value here. All right, it's dot pop. It's dot append low. S is the maximum of itself and the length of S. So you fix violations. Okay. Uh-oh. J is not defined. Oops, it should be B sub I, A sub I, and B sub I. Okay, so actually let's do for A, B, and zip B. Low is the minimum, A and B. Two is correct. It should be 2, 4, and 2. 2, 4, no. Since 3. Should minimum. Oh, if that doesn't work, oh crap, okay. So if you take the minimum here, that doesn't work. Oops. Okay. Hmm. Yeah, so either do we use the maximum then? Yeah, this one is subtly tricky. 10 to the 5th. It's 100,000, right? So here's the challenge, right? N equals 25. So that's 100,000. This implies we need a near linear solution for acceptance. I don't know if we can we do binary search? Just say, hey, this is what we're looking for. Can we do validation? Left to right, right to left. Do right to left and left to right. Okay, so other things I'm thinking, can we perform binary search? Right? Given k guesses, right? Algorithmic k guesses, validation cost of a linear scan each. Right, so that'd be of O of n log n. That would be fine, right? But how do we do the validation time though? Go from left to right, right to left, but then how do I choose the minimum or maximum skip? I guess another question I can ask myself is, right, what would a brute, a brute like? It's still kind of formulating a game plan. Okay, we can't sort. Take either a sub I or b sub I for each ith value from 0 to n minus 1 inclusive. This one or that one is assigned to, well, we have to assign one or the other. We can keep track of states to previous state. What if question? There you go. Put Gadanes for the mark. So for best ending here at each I x, given choices. And 8 minutes left. Yeah, I'm not sure how I want to do this one. Let me look at the, I think I looked at them on another. solution here is 1, 2, 3, 4. So this guy's the min, right? Min, these guys are max. We'll take the minimum from left to right, and then the maximum from right to left, and then where they meet the middle. I'm just pre-process the input from left to right and right to left. This doesn't work. Q. That left to right, right to left. Okay. Oh my goodness. Which is length 1 itself. Find out where it's best in the middle. All right, so question: what if we track, or okay, we delete and say minimums from left to right? So maximums from right to left. And then find the sweet spot in the middle. I don't know if this works or not. Let's align this one. Let's see what happens. B sub j and a sub I. Oh, oops, hold on. Low is the minimum of a sub I and b sub I. The maximum is the a sub j and b sub j, right? Low and high. If I is less than or equal to this guy, otherwise 0. Okay, let's see what happens. It should be 2, 4, 2. It's too many. Oops. This first one, it should be 2. So that's returning 3. That's not right. Not quite right. Yeah, so okay. Still got some room for improvement here for sure. Okay, 3 minutes left. I'm gonna upsolve these two then. We'll call it a day for today. We'll go spend some time with my family. Okay, so yeah, got that done in 1 minute, 49 seconds, 17 minutes, 3 bugs. Oh, this dude's a pretty cool guy. Yeah, this guy's cool too. Maybe he's been here for a while. Anyhow, we have 2 minutes left. I'll just take a screenshot. This is kind of ballpark where I'd be, maybe a little bit lower right after. Oops. After the clock ticks down here. Okay, it's this guy. Today's the 9th. Untest 353. Okay, and I'm going to save this recording and post it to YouTube. So I'll catch y'all later.